Students, the topic for the day is multiple stacks. So in previous topics, we had seen the basics of stack, what is a stack and how it works. We had seen what are the various operations possible on stack. That is push, pop, peek, and these are three operations we had seen on stacks, and we also seen how we can implement these operations, push, pop, and peek, using arrays in the previous topic. And now we'll see what is a multiple stacks, what is the purpose of this multiple stacks, what is the use of it when compared to a single stack. And also we will see how these multiple stacks can be implemented using arrays. So this is the outline where we'll go through what are the lecture outcomes, the actual topic, what is a multiple stack, and its implementation part we'll look at. Next, the summary, and also we will revise the lecture outcomes once again and look at the further reading. So lecture outcomes, after completion of this lecture, students will be able to apply multiple stacks in real-time applications. So while implementing stack, we can implement using arrays and also the linked list. But at the moment, we are discussing about stack implementation using array as a part of Unit 2. And here, when you want to implement a stack using an array, we need to know the size of an array in advance. So because if we allocate less space, less size for an array, obviously this results in overflow conditions if you want to do a push operation. And if you allocate the other way, like if you allocate more space, then it results in the wastage of memory. So there must be a trade-off between this overflow and underflow condition. We need to decide the exact space to be allocated. So a better solution to deal with and to efficiently use the space, we'll go with a multiple stacks where in a single array, we store 2 or more stacks. So this is, you can see a single array we have, and we are trying to store 2 stacks, stack A and stack B. An important point you need to remember is stack A will be growing from left to right, and stack will be growing from right to left. And you can see the indexes also. Stack A, the first value will be inserted 0th index, and the next element at 1 index. Next element we insert at that is, we'll push at 2nd index. 4th element, next element we insert at 3rd index, and so on. When you look at stack B, the first element we insert at n-1, and next element at n-2, and we insert 3rd element at n-3, 4th at n-4. So in this way, stack B will be growing from right to left, and stack A will be growing from left to right. Okay. So the value of n we can call as it's a combined size of both the stacks, the stack A and stack B. So in this way, we can have not only 2, we can store more stacks also. So this is how we write the C code for the push and pop operation for stack A and also stack B. So in this slide, we look at the push operation and pop operation for the stack A. So that's why we call it a push A and pop A. And similarly, the next slide we will see for B, push B and pop B. So at the moment, we are dealing with stack A in this slide. So the push operations for the stack A, we already know stack A is growing from left to right. So the condition we check here is this one for the overflow, because stack A will be growing from left to right, and stack B will be growing from right to left. So at some point, both may meet. So at some point, so stack A is growing from left to right and stack B coming from right to left. So at some point, both can meet and stack becomes this entire array can be full and you cannot do push operation. So that condition you need to check. So this is the condition which checks it if top A equal to top B minus 1. That is, at some point, both can meet. Top A equal to top B. Then the array is full and you cannot do the push operation, which results in overflow condition. Else, that is, the array is not full and both the stacks are not meeting at some point, then you can insert a value or you can push a value. So this is a normal statement as we done in the previous programs, like increment the top variable, the top A's variable, because the stack A has its own top variable. So we'll increment the top variable and at that index, we will insert the new value. So this is push operation. And pop operation, we will check stack A. We say stack A is empty if the variable top A contains -1. So we check whether top A is -1. Then you cannot pop or delete a value from the stack. So we call it as an underflow condition. Else, that is, stack A is not empty. It has some values, one or more values. Then you can return that value in this way and decrement the index, top A index, top A variable index, you can decrement in this. This is for stack A, the push and pop operation. Next slide, we'll see for the stack B. And remember, both the stacks has their own top variables. So stack A has its own top variable. We are calling it as top A. And stack B has its own top variable. We're calling it as top B. So top A will be pointing to the topmost value in stack A, and top B will be pointing to topmost variable in stack B. So now we look at the push and pop operation for the stack B. So we already know stack B is growing from right to left, and also stack A from left to right. So at some point they may meet. So we need to check it. If they meet at some point, then it means the array is full and it's an overflow condition, and you cannot insert a value or push a value to the stack. Else, that is, the stack is not full and there is a space available to insert a value or push a value, then you will you can see decrement the top variable, because here top the stack B is growing from right to left. That's why we decrement the top variable to move it towards left. So, and finally we insert the value at the new index. Similarly, the pop operation, again, the underflow condition, we check in this way. As top B is at the extreme right, the first element of top B at the extreme right, we need to check this condition to see whether top B has any values or not. If top B is called max, it means there are no values in the stack B. And if you pop a value from this empty stack B, it results in underflow condition. Else, else means the stack B is not empty and it has one or more values, then you can return the topmost value from the stack, store in variable val, and you can increment the value top B variable. Okay, so here ends the pop operation from stack B. So this is a summary of this topic. Has in order to efficiently use the memory and avoid the wastage of memory, we are trying to store multiple stacks in a single array. So this is a lecture outcomes revisited. So after completion of this lecture, students will be able to understand the multiple stacks, implement these multiple stacks using array, and use this concept in the real-time applications they develop. And thank you, students.